Hello, today we're going to talk about energy transfer as part of the Physics AQA Paper 1. So let's start off by looking at conductors. Conductors can conduct electricity, but they can also conduct things like heat, and we refer to that as thermal conductivity. The higher the thermal conductivity, that means more energy every single second can be conducted. And you may have heard of something called resistance or resistivity, and it's the opposite. So if you have a high thermal conductivity, you'll have a low thermal resistivity. Infrared radiation can also be used to look at energy transfer. You may have seen a coloured picture where maybe the brighter colours means that it's hotter, and that's because the higher the temperature of an object, the more infrared radiation gets emitted every single second. So that might come out of the windows on a house, for example. Objects at a constant temperature, they emit radiation across a number of different wavelengths, and we can plot that against the amount or the intensity, and then all the different wavelengths are getting longer as we go to the right. So for this particular one at 500 degrees C, we can see a particular wavelength there's the most, but there is a range of wavelengths at that particular temperature that get emitted. However, the wavelengths change depending on the temperature, and as you can see here, the wavelengths get shorter as the temperature goes up, but also it gets a lot higher as well. And conversely, when it's colder, the intensity goes down, but the highest wavelength moves to the right, so the wavelength gets slightly longer as it gets cooler. Now on to the greenhouse effect. On the left here, I've drawn the sun. It's a high amount of energy coming from the sun, and something with a high energy also has a high frequency. And that energy is able to pass through the Earth's atmosphere down to Earth, and that's because it has a really high energy. This energy gets absorbed by the Earth or the ground. Now, as with anything that has a certain temperature, it will release a different wavelength or frequency. So here, the Earth that's absorbed the energy will release energy again. But because it's a lower energy, there'll be a lower frequency of waves that get released. In the air, such as carbon dioxide and methane, will then absorb the energy that's released from the Earth. And then, just like the Earth, the carbon dioxide and the methane will also then release the energy that they've absorbed, and they emit it back down to the ground. And through this process of the energy being released and trapped inside the Earth's atmosphere, that leads to the greenhouse effect. The Earth is getting warmer. Onto the specific heat capacity practical. Firstly, the definition, and it's the energy needed to raise the temperature of 1 kilogram by 1 degree Celsius. So something like water has a really high specific heat capacity, so to heat it up by 1 degree Celsius, you need about 4,200 joules of energy to do so. Then, of course, there's an equation, and its energy equals the mass times the specific heat capacity times the temperature change. As ever, energy is measured in joules, mass in kilograms. In chemistry, you might see it measured in grams. So the specific heat capacity unit for physics is joules per kilogram, degrees C, and the temperature change is just degrees Celsius. Then the symbols we use, E for energy, M for mass, C is for specific heat capacity, and temperature change, delta means change, and then theta is our temperature, sometimes also a capital T. In order to find the specific heat capacity, you'll need to rearrange it, and that's then energy divided by mass times temperature change. The setup that you'll need to get some data, of course, is your battery or power pack. That's then connected to a variable resistor. And then you've got a switch that you can make the circuit turn on and off with. In series, you've got your ammeter, and then you've got your heater. And then in parallel with your heater, you have your voltmeter, and then we can complete the circuit. You'll use the ammeter to measure the current. The voltmeter measures the potential difference. You'll need a stopwatch to measure the amount of time taken, and that's measured in seconds. And these three things can be linked together to calculate the energy, because energy is potential difference times current times time. To calculate the mass, you'll need some scales or a balance. And to measure the change in temperature, you will of course need a thermometer, and it's important you take the temperature at the beginning of the practical as well as the end in order to find the difference or the change. So hopefully you can see then, to measure the specific heat capacity, we can find the change in energy. So we do that using this equation just here, potential difference times current times time, using an ammeter, voltmeter, and stopwatch. To find the mass of the object, we just use some scales, and to find the change in temperature, we measure the start and the end temperature using a thermometer. On to the final topic in this part, and that's insulation. The whole purpose of insulation is to stop the transfer of energy, to stop energy from moving from one place to another. In other words, insulation reduces the rate of energy transfer, so it prevents things like conduction, convection, and radiation from moving that energy away. There are four main types of house insulation to look at, and that's loft, cavity wall, double glazed windows, and using aluminium foil. Loft insulation works by trapping air. So because air is such a poor conductor, because it is hard for one particle to hit another particle to pass the energy along, and also because the air that's trapped can't rise and fall in a convection current. Cavity wall is very similar as well. You've got the inside wall, you've got the outside wall of a house, and in the middle you've got a gap of air. And again, that stops conduction because air is a poor conductor, and also because the air is trapped. It's hard for the energy to pass energy from one place to another because it can't rise and fall very far in a convection current. And you've guessed it, double glazed windows are very similar too. You've got the inside and outside pane, and in the middle, a vacuum of air. So again, really hard to pass energy through because air is a poor conductor, and also the trapped air cannot create very large convection currents. An aluminium foil is the odd one out. So when you have heat leaving the back of a radiator and hitting the wall, that can cause energy to be lost. But if you put a bit of aluminium foil in between the radiator and the wall, the heat that hits the aluminium foil will get reflected back, just like when you look in a mirror, the light gets reflected back into the room. The thing to remember about this topic is we generally always think about insulation trying to keep hot air or hot things warm for longer. However, you can also use these techniques to keep things cool, and it stops heat entering. So just like a flask, you might put your hot tea or coffee inside, that keeps it warm. But you can also put your cold ice water in there, and that'll keep it cool for longer as well because it stops the heat also getting in. Heat will always try to move from a hot air place to a cool air place, and insulation in general stops that from happening. That now brings us to the end of the video on energy transfer. Thanks for watching. As ever, if you have any questions, please get back to me, and don't forget to hit the subscribe button so that you get notified of any future videos. Bye bye.